Welcome, 1033 students. We have Module 7, Homework 2 that we're working on. All right, so let's go ahead and take a look. Now, what we're doing is adding and subtracting fractions, basically, with rational functions. Because we're dealing with rational functions, they can be polynomials, right? They can be expressions, two-term expressions, three-term expressions. So when we're looking at this, we're looking at the properties of fractions. Now, when you were a young kid, you learned that, okay, if you have a fraction of 1/2 added to something like 1/2, let's just keep it simple, that all you do is, since these are the common denominators, is you add your numerators together. So a way of doing that is just taking 1 plus 1 and then adding that together and get 2/2. And then, of course, we know that that's 1. And 1/2 plus 1/2 is 1, right? We know that. And that goes to, for any kind of fraction. As long as the bases are the same, all right, and I say the base, I meant the denominator. As long as the denominators are the same, you can just simply add the numerators. So when it comes to this, it's the same thing. That all we got to do is take and combine, like we did here. We're going to take this problem and combine them like that, because the denominators are in fact the same. And these are called like fractions, okay? So what we do is take and add them together. I'm going to do that mentally, to be honest with you. I don't want to have to rewrite this multiple times just to prove that all I do is take this and basically, if I'm going to rewrite it, I would go ahead and rewrite it like this. Put a plus sign here, put the line there, and make it only 1/7. All right, that's how we're going to do that. I mean, if we're going to play the game of rewriting, that's what I would have to rewrite again. But I'm not doing the rewrite. Okay, so now that we have this, we're going to say, okay, what is 3x plus 8x? So we write that down. All right, so it's going to be 11x. All right, so 11x. And then we add the -10 to the +6, and that's going to give us -4. And then we just put that over 7. And that is what we're going to look for the answer. So it'd be 11x minus 4 for that, and then, of course, 7 for the denominator. Okay? So now we're going to have a couple more of these, and there's not that many questions on this because it's just that simple. It's just a matter of just adding your numerators together. So now in this case right here, for number 2, we're just going to go ahead and add 2x to -1x gives us +1x. All right, because 2x minus 1x. And then we have -5 added to +5 gives us 0. And then we just have x minus 1. Minus 1. All right. And then that's going to give us that as an answer here. Okay. One second. All right, so now we're going to go ahead and look at the next question. All right, so we have the x squared plus 15x minus 15x plus 16. So since it's a negative sign, what you do is you go ahead and take that negative sign and switch the signs of the second polynomial numerator. So it's going to be that 15x is going to be negative 15x, and then you have minus 16. So that negative sign is distributed to both the 15x plus 16. So up here in the denominator or numerator of this, the negative sign just switches the sign. And then you go ahead and put it over x plus 4. All right. Now, when you have this happen, and by the way, this is a plus 15. All right. You're going to go ahead and wipe these out because they're going to, this is a negative 15x. these will wipe each other out. And then you're left with then x squared minus 16 over x plus 4. But then as earlier I described to you in the last lecture with homework 1 of module 7 is that you simplify or you factor to simplify to reduce. So this is factorable because it's a difference of squares, and that's going to be x plus 4, x minus 4. And when we do that, these will cancel or simplify. So then you're left with this as our answer. So our answer that we give is just that. All right, so that happens. So everything that we practice in the other lessons still applies. So we're going to just make sure we keep an eye out for that. So here we have 9x and then plus 5 all over 5. And that's all the answer is that we got to give for that one. Again, we keep on going. We're going to go ahead and add our x's together. We're going to get 2x squareds. We're going to get plus 19x. And then we can see that this has an x that's common to both of them, and as well as this has an x common to both of them. So what we do is factor out an x between this. We're going to get x plus 3. Factor out an x here, because we can't factor out a 2 or anything, right? We're going to get 2x plus 19. Sorry, I'm running into my other problem here. But then these x's will cancel each other. All right? Don't do this. I see students doing this, okay? They go ahead and do this kind of stuff. That is wrong math. Don't do that. That's so wrong. And, you know, I see people doing this kind of stuff, and it's ridiculous, and I don't know why, because they haven't been taught or they just left things to their own assumptions, and it's wrong math. So we have 2x plus 19 over x plus 3. That is the answer we're looking for. All right, even though I ran into the other problem. Sorry about that. All right, now let's go ahead and look at number 6. We're again taking and adding our like terms together. But now remember the negative sign. I personally would like you to practice just simply switching the sign in your head. All right, but I personally would like you to do this in your mind. All right, where you go ahead and do this. And you can do that mentally, really, to be honest. Okay, where you're switching the signs of both of these two terms over here. All right, now this goes ahead and adds to this. That gives me 6x's. And then 10 knocks out negative 10. All right, so that leaves me with 0, but I don't need to write that in. So I have now 7 over x squared, or 6x over 7x squared. Now 1x takes out one of these x's, so that leaves us with then 6 over 7x. So that concludes when we have like denominators. All right, adding and subtracting with like denominators is very, very easy. Now, just as a precursor, when we go into the next lesson, we will go ahead and see that we have unlike fractions, right? So when we have unlike fractions, there's an additional step to make them like fractions, and then we proceed to what we did here.